just want to give a quick intro. My name is Horea Porutiu. I'm a developer advocate at IBM, and I've been focusing on the blockchain platform for the last eight or 9 months here. And as part of my job, I do some workshops, I do some sample coding, I do show developers how to easily get started with this technology. And today I want to walk you through some getting started with Hyperledger. So both the open source, just local technology, but also want to show you a little preview of the cloud service that IBM provides for the blockchain. Awesome. So yeah, let's go ahead and dive right in. OK, so if you need to find my slides, again, you can find them on my Twitter page. They should be pinned right at the top. I'll have some links in here to my, my code. It's all on GitHub. And then all the concepts, of course, you can view later. To see my actual Twitter handle is just this at Horea Porutiu. It will be on the bottom of every page. OK. So the agenda today, first I will just talk a little bit about what is Hyperledger. And after that, I want to show you how to download and get started on your local computer. So I'll show you where you can download all the Hyperledger Fabric. I'll show you, there will be some scripts you have to run to actually start the Fabric on your computer. So I'll go ahead and do that too. And then I'll show you this hello world, or just your first smart contract. So hopefully you can at least get some sort of knowledge of how to deploy your first contract. So after I do that, I'll show you this proof of concept I've built using the blockchain cloud service, and kind of show you why I built it and kind of how it compares to this Hello World application. So I'm trying to kind of bridge that gap, is like this Hello World, and then take you to the next step of a little bit of more complex application. OK, so with a show of hands, how many know about Hyperledger in this room? OK, this is good. Nice. So how about blockchain? Who is familiar with blockchain somewhat? OK, so most people. OK, so Hyperledger is this open source project under the Linux Foundation. And what you see here at the top is we have all the frameworks. So there's Fabric is the most mature framework, and they have this way of grading how mature the project is. So there's Hyperledger Burrow, there's Fabric, Indy, Iroha, and Sawtooth. So today I will focus on Fabric. So IBM is one of the main contributors to Fabric. So I'll focus on that. What you see on this picture is you see the channel support for Fabric. So that's one of the main features of Fabric, is this channels. And I'll show you that as part of my demo. Composer, you see right under the frameworks, you have these tools. And today I'll talk about a tool called Composer. And this Composer is just simply taking the complexities away of developing with Hyperledger Fabric. So it's just trying to make this development a bit easier. And they have their own modeling language, and they have smart contracts based on JavaScript. So I'll show, that's what I'll be mostly focusing on today, is this Hyperledger Composer. OK. So one question I get very frequently when I do this talk is, what is the difference between Hyperledger Fabric and Hyperledger Composer? Again, this main thing I want you to understand is that Fabric is always necessary, but Composer just accesses Fabric in an easy-to-use manner. So Composer is optional, but I think it's a really good way to get started developing. And under the hood, Composer is really just calling the Fabric APIs, and it's really just building on top of Fabric. So some of the key concepts that we will learn about is participants, transactions, and assets. So these are the keywords that I'll mostly be focusing on today. And that's the keywords that Composer uses. OK. So here's the link for actually downloading the Fabric environment for your local computer. Of course, I don't recommend doing this now because it will take some time to actually download. But after, if you want to go home and try this out, I leave this link here for you. So once you actually download the Fabric on your local computer, you'll have some scripts that you'll need to run. The first one is download Fabric. So I've already done that on my computer. And that was just taking the actual Fabric and putting it on your computer. The start Fabric script is what I will show you later today in my demo. And that's going to create some containers. And the 4 containers that it'll create, one will be a database, one will be an orderer, one will be a peer, and one will be a certificate authority. So I'll kind of go a little bit more about that when I actually run the script. And the last thing we have to do is actually create these peer admin card. This is the credentials that will give us, or these are the credentials that is basically admin access to the network. So we have to prove with our public-private key pair that we are the admins of the network. And that's what this script is doing, is creating these credentials for us. So I talked a little bit about this modeling language. So this is Composer uses this unique modeling language, and their file is called this model file. So that's just really the data schema of your actual application. So the 4 things we really have to worry about is the namespace, the participants, the assets, and the transactions. So we have to define these 4 core features. The events are optional. I will not show that for the sake of time, but know that there is events as well. So this is basically what you'll need to define, and I think this is really the most critical part of building your application, is this model file. So if you spend most of your time actually coming up with a very good model, I think that is really the key to a successful blockchain application. So really take the time, I think, really to understand who are your participants in your blockchain network, and what transactions and assets do you have. But really, the participants is at the core, right? We want to ensure that you know, we have some value being traded on the blockchain. So again, this first part of defining the model is I think, the key and the most important part. So here I have a very simple kind of like a hello world model file. So this model file, I will show you deploying this with Composer as part of the demo. So first thing, we have our namespace at the top. And after that, everything we want to reference in the blockchain will be coming from this namespace. So once we have defined our namespace, we can define our asset. So we see here we just have a very generic asset called commodity. And we have 5 different fields for this asset. So you see we have 3 strings. We have the trading symbol, the description, and the main exchange. And we have a double. And then the really key part is this arrow notation you see. And that's simply just a reference to a different part of the blockchain. So we're referencing a trader here. So right under our asset, we have defined our trader. So what that arrow is saying is that every commodity has to have a trader. So again, we have our asset. Under that, we define our participant. So we have this trader. And you see here we have this identified by. So a lot of times when you're working with blockchain, you'll want to query a particular participant or an asset and see exactly what has happened to this asset as it has moved along the blockchain. So to do that, you have this unique identifier, this trade ID, and you can query by this trade ID and then see kind of what has happened to this asset as it goes across the blockchain. And I can show you that in a little bit here. The last part is the actual transaction. And this is something we actually have to implement. So this is a very simple changing of ownership. So you see this transaction takes a commodity, and it takes a trader. And you see here that for trader, we have this new owner. So all we're doing is we're taking a reference to the asset, and we're taking a reference to the trader, and we're just updating that owner. So I've shown you the data schema here. Next, I'll show you the implementation of this transaction called trade. So here is the implementation. So this is the actual smart contract. May be referred as chain code in Hyperledger terms, Hyperledger Fabric terms. So you see here, this is written in JavaScript. You see we have some promises. So that is something you'll have to be familiar with to develop this smart contract. So the first thing we do is just assign our actual new owner to the commodity. And what's important from this slide is this get asset registry. So this is the Composer API. So that's basically taking this namespace, the org.acme.mynetwork.commodity, and it's going into the blockchain and getting that actual asset. And then once we actually get it, we have this update API, right? And it's just going to simply update what data we have given it. So all we're doing here is taking this new owner and updating the owner field of the commodity. So this is kind of your hello world, just changing the owner. So as we talked about earlier, there's some kind of this conflict with these public blockchain networks and this private network. So kind of like the MC is talking earlier, this Ethereum has this kind of conflict. So the access control rules is really what makes this network private or permissioned. So these rules here is where you can specify who in your network has access to what. So by default, we have a very simple, like everyone has access to everything. So in a more complex scenario, you want to have reference certain participants and say they only have read access. Maybe some different participants have write access. So this is where you will do that. And this is kind of this private or permissioned architecture. So what I've shown you so far is this data schema. I've shown you the actual JavaScript implementation, the chain code. And then I've shown you this security access control rules. So these are the three main files that Composer works with to create your business network. So once we create this business network, we will have a REST API that we can deploy, and we will be able to access the blockchain with our API. So our API will have exactly what is defined in the data schema. So it will have our asset, it will have our trader, and it will have our trade transaction. And we'll be able to post, we'll be able to get, we'll be able to put. So that's what this goal for deploying this network is, coming up with this API. And after you do that, you can simply hook up this API with your front-end code and basically update the network that way, just with using this, this API. OK? So this is where Composer comes in. So once you finish developing these three files, you have this command called Composer archive create. And this basically zips up your three files into one file. Nothing complex here. And this file is called the Business Network Archive. Some refer it to as a banana file, BNA, banana. So that's really what Composer is doing. It's taking these three files that we have defined and creating this one Business Network Archive, this one zipped file. And to actually deploy the network, we have to have some credentials. So that's where these network admin card comes in. And we have a script for creating these credentials. So once we have our banana file, we have our credentials, and we can actually deploy our REST API, and we'll have a nice Swagger has this nice documentation for the REST API, which I'll show you in a minute here. Okay, so for the sake of time, I'll leave this for later, but this is an online playground where you can go ahead and test your code. So without installing any dev tools on your laptop, you can go ahead and take the code I've shown you here and deploy it there and do some transactions and see the owners being updated. So this is, I think, a nice tool just to test quickly your smart contracts. OK, so time for the demo here. OK, so basically what I have done, so what you see here is this GitHub. So this is called a code pattern. So part of my job at IBM is creating these open source code patterns to help developers on board with the technology. So this is one my coworker created, but I think this is a really good way to get started. And this is kind of the code that is in this repo is what I have just shown on the slides. So it's the exact same code. And here you'll have all the scripts that I talk about, the start fabric, the download fabric, the create peer admin card. You have all the scripts in this nice repository. So I'll go through some of these steps, and at the end, we'll create this REST API. OK. So what's nice about this GitHub, it gives you a nice diagram of what exactly we'll be doing. So first we install the dev tools. I'm going to skip that step just for time. Then we're actually generating the Fabric network, and we're starting the Fabric. And then we are basically just generating this banana file, and we're deploying it, and we're creating this local API, local server. So that deployment is step 5 there. So we have a few prerequisites here. I'm not going to go through those here. But the main tool you'll need to install is this Composer CLI. So that's what I'll be using to package this 3 main files into our BNA or banana file. And then the last tool, this Composer REST server, this just has some code to create this nice-looking REST API documentation. So this Composer REST server package is basically just creating this nice REST API for us. OK. So the first thing we should do is actually start so first we just clone the directory. I've done that for now. And now let's go ahead and go into OK. So you see here the same code I've shown you earlier. So we're in our actual directory here. So first thing we want to do, I'll just delete these cards from before, clear, and then we'll start the Fabric. So this will take a little bit of time here. But what you see at the bottom is these containers being stopped. And then they will be restarted again, and they'll be running. So the 4 things that I've mentioned before is the database, the CouchDB, the orderer that will take all the transactions and actually place them in some sort of order. The peer will be running the smart contract on it and generating some sort of output. And then the actual certificate authority that will give out the public-private key pairs to the participants. So we see here that we have started our network. Everything looks good so far. So the demo gods are with me right now. So next, we want to actually create our admin credentials. So we have this create peer admin card. So this, in a second, will create these credentials for us. So you see here we have this peer admin at Hyperledger Fabric version 1. That's our actual card here. So now we have created our credentials. Now we actually need to use this Composer archive create to package our 3 files into something we can deploy. So the nice thing about this repo is it automates all of that for us. So if we go into our package.json, we can see this Composer archive create here. And all it's doing is it's taking all the 3 files in our directory, And it's taking that data schema, it's taking the JavaScript code, the logic, and it's taking the permission files. And we give it a directory to put those files in, and we say dist/mynetwork.bna. That's where you will output this file. So again, just to show you these separate files, I have the JavaScript implementation, what I've shown earlier. I have the actual data schema, and then the actual permissions file. Same exact thing. So if I run npm install now, it should create this actual banana file in my current, in this dist directory. So I'll run npm install. So hopefully in a couple seconds here, we should get this nice output. So we see again, we have this output file dist/mynetwork.bna. So we'll need to give that file to Composer REST server to actually deploy our API. Okay, so after that, there's some additional things we can do. I'm not going to test for the sake of time, but we have some tests in here. And then we can actually install the network. So this is the key part, and it's taking in my actual admin card, and it's taking my banana file, and it's installing the network here on the peer. Okay. Okay. So I'll go ahead and run this. We see that the command succeeded, so now we've installed the network. And the next thing we have to do is actually instantiate the network. So we have to start the network, and if there's any sort of constructor, any sort of data that we build at the start of the network, this is when that will happen. So let's go ahead and start the network here. Okay. So should take a couple seconds here. We give our admin card. We give our our admin card, and then basically we'll start the network for us. We should see, yeah, perfect. Okay, so we start the network. We can actually ping the network to see if it's working. I'll not do that right now. So the next thing we can do is actually create our API. So let's go ahead and run this Composer REST server. So this will ask, okay, clear. So this will ask us for our actual business network card. So that will be the admin card we have made earlier. So admin at my network. Here it asks for namespaces. If you say yes, it will have the org.acme.commodity. I'm going to say no for making it look a little nicer. So we'll just say commodity instead of org.acme.mynetwork.commodity. So I'll say never. And I'm not going to secure it for now, just for the sake of time. So I'll ask, do you want to enable authentication? OK. So I'm just going to say no for now. So it's going to go into the types of our network. And now we've generated our REST API. If we click this, we should see our REST API here. So again, we have the commodity. If we don't have any commodities created yet because our constructor didn't create any. But if this is where we can go ahead and do like a get call, and then we would see all the commodities in our network. This system is like the entire history of the blockchain. So for the system now, we should just see something like a we see the network is instantiated, and I believe just basically just the first installation. So let's check that right now. Let's zoom out a little bit. Yeah, so you see here we have the start of the network, and then we have added the actual admin here. So what I can do, I can actually add a couple traders here. I'm not going to go through the full flow for time, but I can add a couple traders, and all of this JSON that we need is in the repo. So here's the data schema for the trader. I'll just create one quickly. I'll post it here. And if we try it, it should give us, hopefully, 200. Awesome. So we see here the date. And if we go into our system, we should have this as well. OK, perfect. So we have this add participant. We see that the admin invoked it. So that's what we have with the system record. So this is how you get your first Hello World application running. Once you have this API running, you can go ahead and connect to your front end, and then you can have this whole history of transactions. You can have more complex queries. I haven't shown that, but I'll show this in the next demo. So you have more complex queries, but this is kind of the basics of getting started, just getting to this point. So now I want to switch gears a little bit. So you can kind of see this shirt I'm wearing is this IBM blockchain in collaboration with Brooklyn Roasting. So this is a proof of concept I've worked on using the blockchain cloud service. So I want to kind of demo and show you that now. So I want to show this hello world and then go into a little bit more complex architecture and schema now. OK, so I'll close this up for now. Add this up. OK. OK. OK, so this is the main page for the activation. So really the goal of this project was to show this transparency for all the key suppliers in the supply chain. So the goal of Brooklyn Roasting Company, so this is the partner we worked with, their goal is to show this ethically and sustainably produced coffee. So part of that mission is showing this fair price that is paid for the coffee. So what we have here in this project is we have their actual industry-compliant documentation that shows that they gave a fair wage to the coffee growers that they paid. We have shipping details, such as like a packing list. We have import details. And then we have actual roast details. So before the coffee is actually brewed and created into a cup of coffee, the Brooklyn Roasting Company goes ahead and tests it, critiques it, says, oh, it's maybe not so good, or it's really good. So those are the main kind of components. So again, I think what's important to understand with blockchain is that really 99% of the work and investment comes as you're creating the network. Once the network is deployed and out there, there's not really much to be done, right? But it's a huge, massive investment to actually get it started, right? You have to get all the different parties, all the different suppliers agreed on the same exact terms. You have to actually, build the network like we have done here. It takes a lot of time and investment, right? Once you actually launch and deploy, it's not that much work. So I think that's the key part is, do we need a blockchain? And then actually taking the time to work with all the participants and suppliers involved and say, hey, are you OK with these exact rules that we have gone by in this smart contract? And at the end of the day, someone needs to approve all these transactions, right? So there has to be someone, either an external organization or someone that you give permission to actually approve these transactions. So there's something called like an endorsement policy, which you can set up in your Hyperledger and saying which member is actually going to approve the transactions. How do we know it's actually a correct or incorrect transaction? OK, so for the next 10, 11 minutes, I want to focus on the different participants and different parties involved. So the first party I'll talk about is the actual grower. So the grower is this Ethiopia co-op. And we see here, on July 21st, 2017, we buy 150 bags of this coffee. So at this point, Brooklyn Roasting has a document that says, look, when we bought these bags of coffee, we have given this tax to actually invest in the local community, and this is their way of proving this fair trade premium. So if I click on View the Blockchain, it should actually query my blockchain, and it will show me exactly what has been invested. So we see that they have invested in road infrastructure. Let me zoom in a little bit. We see they've invested in road infrastructure, they've invested in school classrooms, and food security. Also, you can see that the total premium they have invested is $182,000. So you may be thinking right now, like, okay, this is just random data. Where are you getting this data from, right? It's like, you're just showing me this data. So now we can click on the View Original Document. So Brooklyn Roasting was nice enough to actually let us publicize these documents. So what you can see here is this premium invested, $182,000, exactly what I've shown you earlier. You have the school classroom addition, the funds invested, $30,000. You have the road infrastructure and the food security. So these are some of the fields we thought were important, and Brooklyn Roasting thought were important to show to all the customers, the different suppliers. So this is the way of showing this fair trade and ethically produced and sustainable coffee. So we have talked about the first part of our journey, which is the grower. So next, we will have to actually ship this big, very huge batch of coffee. I'm not sure, maybe 1,000 kilos or a very big amount. We ship this from Ethiopia to the United States. So now we need some sort of proof from the shipper that, we have packaged all your coffee on this date, shipped it in this container, it'll arrive on this date. We have to have some documents here. So that's the next part of the story here. So we can go back and just to show you kind of my actual API that's running. So this is the API that I have available for this coffee bean demo. So this is the same Hello World API, but just with a little bit more complex data schema. So instead of only one participant, I have four or five participants. So we have the grower, we have the shipper, we have the retailer, right? So it's really that same, pretty much that same thing, just added a little more complexity to the schema. So if I actually go into submit fair trade data, so you can think of this as we have a different interface for this grower. They have their own application, they sign in, they authenticate, and they have access to this REST endpoint. And they're able to submit, or Brooklyn will actually submit this fair trade data through this endpoint. And only they can submit this data. So we actually do a get here to see what's actually has been submitted already. So again, it's that same exact data that was showing in the front end, right? It's really just doing a simple get call to this. So you can see, again, the road infrastructure here, the food security, classroom addition. We have some more data that was not shown in the UI, like the actual batch ID. So you can imagine if there's 100 or 200 different huge batches of coffee, each one will have this unique ID, so you can actually see the process for each bag. Okay, so yeah, when you click on this view the blockchain, it's just making a call to my API that's running in the cloud right now. So second step here is we have to show these packing details. So again, I tell you, we have to have some data for actually shipping. So this is the next step here. So we click on view the blockchain, and now we should see some more details about the packing list. So you can see the voyage number, the invoice number. Something interesting is that this has a reference to the grower. So you're saying who actually gave these beans to be shipped. You're saying grower 0201. So you're saying, okay, who's grower 0201? If we actually go into our REST API, if we go into grower, do a get, we should see our grower 0201, okay? And you see here, that's just simply the Ethiopian co-op, right? So we see here, that's who is actually submitting these beans. And you see here that who's actually going to receive the beans. So this is this trader. Oops, this trader 0791. Okay, if we go into trader, we'll see who's actually picking up the beans. Do a get. And we'll see that here. Okay, so I was already loaded. So you see Royal Coffee is actually receiving these beans. OK. Again, we see the ship name, Northern Magnum, and we see the bill of landing number, 961. So we can view the original document. Same thing. This is all coming from the coffee co-op. So this is their proof that we have actually shipped this data or this batch on this day. So we see the date is 2017. This Royal Coffee. Bill of landing number, again, you see that 961 number. You see the container number is blocked out. That's just part of our agreement with Brooklyn Roasting. They didn't want to show that detail just for security purposes. But everything else they have let us show publicly. So you see here that container number is redacted just for security purposes. OK, so we've shipped the coffee. Next thing, about how long does this journey take? 2 weeks, 2.5 weeks? 2.5 weeks later, we actually received the container. So now we have to go into the container and see, like, did we actually get the amount of coffee that was shipped? Is there damage? Did it spoil over the ocean? Is there insects? We have to confirm that we got a good shipment. So we can view the blockchain here. Again, it's just calling my REST API here. So we see, are there holes in container? No. Was there any condensations? How many bags do we expect? Was there insect activity? And that, again, that document is just coming straight from this importer. And they're the one that is actually receiving this shipment. And you can imagine this big importer of coffee has, thousands of I don't know. In a normal month, maybe they have hundreds of these shipments, right? So they have to have good organization to keep track of all of these. Again, you see on this documentation the bags expected, condensation, holes in container, and we have people that have actually signed off on this saying, look, this is what happened on this date. We verified it. And that's just coming, again, straight from this submit inbound weight tally here. OK. Yeah, so same exact info here that you see on the front end. OK, so the last step, which I think is really the coolest part, is this cupping. So once the retailer buys this coffee from this big warehouse, they go ahead and critique. So you can imagine, like, I don't know, 10 of these coffee connoisseurs sitting around, sipping a little bit. Oh, aftertaste is not so good, or oh, it's too acidic, or the taste it's good, but it's maybe not perfect. So they have their own internal critiquing system. So this is what you'll see with this part of the blockchain. You'll see who actually, Brian actually critiqued it, what was his final score, and you see above that, aroma, 9, this is all out of 10. 9 out of 10, acidity, 8 out of 10, flavor, 8 out of 10. Same thing, we have this original document to show this here. OK, again, same thing. You see Brian, the aroma, the flavor. We have some more descriptors, like it tastes like blueberry a little bit, lime, honey. OK, so the last part that I want to show you is this actual your cup of coffee. So what we did at this, it was this big food festival. So what happened is every cup had this barcode on it. And basically, when you buy a cup or go up to get a cup of coffee, the barista or the retailer will scan this cup. And when they scan the cup, they're just simply calling my REST API, and they're posting to the blockchain. So they're saying, look, at this exact time and date, I've sold this cup of coffee to this person. And we say, I have, Brian was the one that sold it. The drink was iced coffee, served at this time. We have all this information. And maybe this is not necessary in a real-world scenario, but we thought this would be a good way to show some of the additional functionality. So now, let me show you the cloud service running. So this is the IBM blockchain starter plan. So right now, if you sign up, you should get a month free to develop. So right now, you'll see my channel. Right now, I only have one channel. If I wanted to create different channels, I can do that. And basically, I'll have private transactions within each channel. So it's almost like a blockchain within a blockchain, kind of. This is what Fabric offers. So again, we have our blocks here. We see the last time is 50 minutes ago, so I'll post a new cup. And in a couple seconds here, you should see it posted to the OK, so does anyone have a random number, 3-digit number? What? 66? OK, I'll try that. Maybe not the best thing to do, but I'll put that in. So we should see this new block being added. So it should be 721. We should see that 666 ID into the blockchain now. And once I do this, once it's successfully in the blockchain, I can query and I can show this relevant details. So again, you see this 15 seconds to the last transaction, 721 blocks. In a second here, we should see the details of this block. And we should see that 666 number right here. So yeah, you can see it. So now we can query the blockchain for that specific number. So you can imagine I have just got my cup of coffee, and say I go home and I say, OK, I want to see the history of where this cup of coffee came from. So here I put in my cup of coffee. In a couple seconds, we'll get all that detail. So we'll get the exact time. So it's today, 12:08. This is the type of drink. This is your cup ID, the type of beans you have, and the roaster. And then you have the full timeline after that, like, OK, this is where the cup came from, but where did those beans actually come from, right? And you have this timeline. And that's exactly what I showed you previously, is this history of exactly where the bean came from. So I'm running out of time here, but maybe I'll show you 1 more minute of the code. And then I will be out of here. So the last thing I'll show you is this blockchain bean code. So this is all online. I will give you the repo name at the end. So I'll show you the code here. So again, I think the most important part is the model file. So this is what we have here. We have all of our different participants I showed you. We didn't talk about regulator, but we have grower, trader, shipper, retailer. We have our cup of coffee. This is what I showed you earlier. We have the cup ID. We have the drink type, barista. This is the schema for it. And then you have this big batch of coffee where you have multiple cups of coffee coming from. So this is where you actually put the data for the fair trade premium, the packing list, the weight tally. This is where the conditions come in. And then my favorite part is tasting, the cupping details, how good it tastes, right? So this is the coffee asset, the big batch. And then what I showed you earlier is this pour cup, this transaction pour cup. It just takes in a cup ID, and it generates this timestamp for us, right? And that's more or less it. That's the schema. And then the actual logic is here. I can show you a simple one. So basically, all we do is we get our actual coffee from the blockchain. So we get this asset registry, as I showed you before, is this Composer API. And then we just set all the fields of the coffee. So we set the invoice number, we set the bill of landing number, we set the load of vessel, and then after we create an event. I didn't show that, but at the end, we just update. And that's pretty much it. OK, so I will leave you with that. So here are all the things I have just shown you. The GitHubs are all here. If you want if you have any questions, here is my contact info. And basically what I showed you today is how to get started with this Hyperledger Fabric. So there's this local open source. You can install on your computer, test locally, but you will not get this nice UI to actually inspect all these. You can still do this inspection, but we have this nice UI. You can create different channels. So I've shown you the open source version, and I showed you a little taste of the cloud version as well. So hopefully you understand now this data schema is really that most important part of creating this network, and then basically implementing a few transactions there on the network. So I've shown you that, and I've shown you this proof of concept we have built with Brooklyn Roasting, which is taking some of their supply chain data, and for the purpose of showing all of their suppliers a more efficient and streamlined process to show, okay, this second I've received this document, we've shown exactly what time we received it, we've signed off on it. So increasing this transparency for both the customers and the suppliers. And then just for fun, every time we actually gave a cup of coffee, we added on the blockchain too. So hopefully you have learned at least something about Hyperledger, and thank you so much for your time.